Do any of you still watch the evening news? Have you noticed that lately they start the broadcast by saying good evening? Then spend 30 minutes telling you why it's not? Anyway, let's talk more about probability. So, we've previously talked about mutually exclusive events, events that have no outcomes in common. And we had a special rule for calculating the probability of A or B whenever those two events were mutually exclusive. Today we want to talk about a different kind of special pair of events, and those are called independent events. And independent events are a situation where we say that events A and B are independent if the outcome of one has no impact on the outcome of the other. So let's consider a scenario. There's a woman and she's got 4 coins in her pocket. 2 quarters and 2 nickels. She's going to reach into her pocket and she's going to grab a coin and she's going to look at it. She's going to put it back in her pocket. And she's going to pull another coin out of her pocket and look at it. And let's call the event Q1 the event that on that first pick is a quarter. And let's call the event Q2 the second pick is a quarter. Then we can determine that the probability of Q1 occurring is equal to 2 out of 4. It's not unreasonable to think that if she's just going to randomly grab a coin out of her pocket, that all of the coins are equally likely. So this is equal to 1/2. And so then we ask, what is the probability of her getting a quarter the second time if she got a quarter the first time? Right? So the first time she picks a quarter and we ask, what is the probability that the second pick she gets a quarter? Well, because she put that in her pocket, she put the original coin back in her pocket, then the probability of her second pick being a quarter is still 2 out of 4. What if she would have picked a nickel the first time? Right? If the first time she, instead of getting a quarter, she picks a nickel and she puts that back. Then the next time, her second pick, what's the probability of her getting a quarter? Well, it's still going to be 1/2 because there's still 4 coins in her pocket and 2 of those are quarters. Well, let's change this up a little bit. So let's keep the scenario where we have a woman with 4 coins in her pocket, 2 quarters, 2 nickels. And let's keep the events that her first pick is a quarter as Q1, and her second pick is a quarter as Q2. But instead of her reaching into her pocket and picking a coin, looking at it and putting it back, let's say that she picks her first coin, looks at it, and doesn't replace it before she draws her second coin. Let's look at what happens to the probability of Q2. So our first situation is Q1 occurs. So in the situation where Q1 occurs, that means that she did pull a quarter the first time. That means what's left in her pocket are 3 coins, quarter, and 2 nickels. And so our probability of Q2 occurring in this case, we have 3 coins. Let's again say that they're all equally likely, but we only have 1 quarter. So our probability here of Q2 occurring is 1 out of 3. But what happens if Q1 doesn't occur? Meaning that first pick, she picked a nickel. Well, then let's think about the 3 coins that are in her pocket. We have a quarter, and a nickel. And so now the probability of her second pick being a quarter, we again have 3 coins. We're assuming that each of those coins is equally likely, but 2 of them are quarters. So now the probability of her selecting a quarter the second time is 2/3. And so because depending on whether or not that first draw was a quarter or not changes the probability of this second event, Q1 and Q2 are no longer independent. And so in the case whenever we replaced the coin, the outcome of Q2 doesn't change depending on whether we first draw a quarter or a nickel because we put it back. And we still had 4 coins, 2 quarters, 2 nickels, regardless of the first outcome. But in the situation where we don't put the coin back, what occurred with Q1 changes the probability of Q2. And this is the definition of what it means to be not independent. But if we have 2 events that are independent, then we get a nice little situation here where if A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. And so in this case, if we were replacing the coin after drawing this, then we had a probability of getting a quarter the first time of 1/2 and a probability of getting a quarter the second time as 1/2. And so if we wanted to ask what's the probability of drawing 2 quarters, then we could answer that by saying, well, the probability of drawing 2 quarters is just 1/2 times 1/2, which is equal to 1 and 4. And we can calculate that directly. But it's very important, just like with mutually exclusive, that we only apply this rule when we have independent events. The next thing that we're going to have to work on is how do we calculate these probabilities of or and events when we're not in one of these 2 special cases, when we don't know whether they're mutually exclusive or independent.